Welcome back. Today's explainer is diving into something that sounds straight out of a science fiction movie, but is actually a rapidly advancing scientific reality. We're talking about brain-to-cloud integration, the concept of the infinite mind. It's a topic that's honestly as thrilling as it is complex, so let's jump right in. I want you to just pause for a second and really ask yourself, what if you could access the internet using only your thoughts? Seriously. Instead of pulling out your phone, typing a query with your thumbs, and reading the screen, imagine simply thinking a question and instantly receiving the answer straight into your consciousness. You'd literally be backed by the computational power of global servers. That is the staggeringly bold promise of this technology. So here is our roadmap for today. We're taking a structured journey from biological reality all the way to our speculative future. First, merging mind and cloud. Second, the bridge technology today. Third, nanobots and cloud architecture. Fourth, transforming human capability. And finally, the ethical firewall. Okay, let's start with part one. Merging mind and cloud, the biological bottleneck. You know, to really understand where we're going, we have to look at where we've been. Human history is essentially just the history of tool-making. The wheel, that extended the leg. The telephone extended the voice. The internet extended our memory. Brain-to-cloud integration represents the next, and without a doubt, the most profound extension in this entire evolutionary chain. It's about forging a direct, real-time link between biological intelligence and cloud infrastructure. Think about the massive contrast going on inside your own head. Your brain has roughly 86 billion neurons, processing immense amounts of sensory data in parallel. Internally, you are lightning fast, but our physical output, it is agonizingly slow. We are stuck typing with our thumbs or speaking just a few words at a time. This huge gap between our internal processing power and our limited output bandwidth is what researchers call the biological bottleneck. And this tech, it aims to completely shatter it. Now, we didn't just wake up here overnight. The science has been accelerating for decades. It started way back with Norbert Wiener's 1948 concept of cybernetics, moving to 1998 when we saw the very first human brain-computer interface. By 2019, the specific brain-to-cloud framework was officially formalized. And here we are in 2025 with rapidly expanding human trials, all pointing directly toward futurist Ray Kurzweil's famous prediction, seamless brain-to-cloud integration by the 2030s.
Moving right along to part two, the bridge technology today, brain-computer interfaces.
Before we can seamlessly merge with the cloud, we have to build the hardware that bridges the gap. So what exactly is a BCI? Well, a brain-computer interface is a system that entirely bypasses your muscles and your normal neuromuscular pathways. Instead of your brain telling your hand to move a physical mouse, the BCI steps in, reads the electrical action potentials directly from your brain, and translates those raw neural signals into actionable commands for a computer. It's actually super fascinating to compare the two current giants of this industry because they're taking radically different approaches to getting these sensors into the brain. On one side, you have Neuralink using a highly invasive approach. They utilize a specialized surgical robot to implant their N1 chip directly into the motor cortex. But on the flip side, you've got Synchron offering a semi-invasive method with their Stentrode device. Instead of open brain surgery, they literally thread the sensors up through the jugular vein. And if you're sitting there thinking this is still just some niche academic pursuit, consider this massive number, $2.3 billion. That is the estimated valuation of the brain-computer interface market in 2025, and it's growing at an incredible pace. Serious heavy-hitting capital and major clinical trials are absolutely fueling this technological race right now. Which brings us to part three, nanobots and cloud architecture, the ultimate system. So how do we actually scale this up to connect a human to the cloud? Let's walk cleanly through the four distinct layers of how a brain-to-cloud architecture functions. Step one is signal capture. That's where electrodes detect your neural electrical activity. Step two is transmission, where that digitized data is wirelessly transferred out of your head. Step three is where the real heavy lifting happens, cloud processing, where massive AI servers decode your raw neural noise into actual clear intent. And finally, step four is the feedback loop, where the cloud sends information or stimulation directly back into your brain. Now, to make this fully seamless in the future, the source material points to a highly speculative yet totally scientifically grounded concept, neuro-nanorobotics. We're talking about billions of microscopic robots navigating your brain's blood supply. Endoneurobots would sit at axon segments to monitor firing. Gliobots would integrate perfectly with your support cells. And synaptobots would literally be in there monitoring chemical transfers at your synapses. It's wild stuff. And the only reason researchers are looking at nanobots is purely about bandwidth. To achieve true, real-time cloud computing connected to human thought, these future nanorobotic fiber optics are theoretically projected to handle up to 10 to the 18th power bits per second. That's a billion bits every single second. That is a staggering data capacity that would make real-time cloud computing a direct, unnoticeable extension of your own consciousness.
All right, moving into part 4, transforming human capability from healing to telepathy.
We're shifting from the systems engineering phase over to the practical applications. The absolutely crucial point here is that while current human trials are strictly medical, doing incredible things like helping patients with ALS communicate or curing paralysis, the ultimate endgame goes so much further. We're looking at cognitive enhancement, like memory prosthetics, where your brain could theoretically back up data to the cloud and totally seamless AI integration. We're also looking at revolutionary communication. Yes, we are talking about brain-to-brain telepathic networks.
This echoes a mind-bending philosophical concept from researchers Clark and Chalmers, known as the extended mind thesis. It argues that cognitive processes need not be confined to the brain. Think about it. Your smartphone is already an extension of your memory, right? With BCI, your mind might literally exist, at least partially, on external servers. The line between your biological self and your digital tools could completely dissolve.
And that leads us right into our final section, part 5, the ethical firewall risks and realities. Because look, with access to the deepest parts of the mind comes some terrifying vulnerabilities. When your biological brain becomes a network device, it inherits all the risks of a standard computer network. Eavesdropping is no longer just someone reading your text messages. It's a malicious actor reading your thoughts and your memories. We could see injection attacks sending false sensory signals directly into your mind. Imagine a denial of service attack on a paralyzed person's motor controls, or a hack that corrupts the very AI model decoding your identity. Naturally, this entire field has sparked an intense ideological clash, and there are two very distinct camps here. On one side, you have transhumanist optimism, which focuses entirely on reducing immense medical suffering, merging with AI to stay relevant as a species, and transcending our biological limits. On the other side, bioethical concerns urgently warn about preserving core human dignity, protecting our fundamental right to cognitive liberty, and preventing a terrifying new era of biological inequality between the augmented and the unaugmented. Both sides make incredibly compelling points based on the source data. So we'll wrap up today's explainer by leaving you with a single, lingering question to think about. If your memories can be stored in the cloud, are they still yours? The philosopher John Locke argued that our identity is fundamentally tied to our memories. If we externalize them, back them up, or process them through corporate servers, what actually happens to the self? This isn't just philosophy anymore, folks. This is the reality we are actively engineering. Thank you so much for joining me to explore this source material today. Keep learning, keep questioning, and I'll catch you next time.